Hello there. I think this is working. I will check.
Hello.
Yes, I can hear myself perfect. Uh, how's it going? Whomever is out there. Oh, did my oh, no way, did my mouse just die? Oh no. That's awful timing. I'm gonna get a new mouse because my mouse is dead and one moment. I can't believe I've done this. Uh, Let me turn down the mic so I can search. I'll be right back. Um, where's testing, testing, testing. Okay, I think it's working. Uh, can anyone hear me? I am back, I believe. Oh my goodness, thank you. My mouse will probably die again, but hopefully I'll just be in Vim mode by then and can just, I don't know. I need a new mouse. Hello, Martinez? I hope I've not butchered your name, but welcome. Um, and hello, anyone else who watches this in the future. I fixed my microphone. Very, very proud of myself. I think it's working. Yes, it is. Okay. Anyway, so yeah, I'm working on this terminal UI interface. This is a demo view of just trying to render a lot at once, and it's updating pretty quickly. I can tap the arrows on my keyboard to move this little logo around to a different alignment. I can show the actual code that renders this. It's pretty easy to write. That's kind of the whole point. There's a couple other examples here. Well, this one's less exciting. It's just a frame with different alignments, so you could put things in different corners of the view. And I have this little list example where I can go up and down in a list item. And then here's the fancy 60 frames per second ish. I'm not entirely sure. But it's really smooth, and numbers are incrementing and flowing upwards in the background. So it's working all right. I'll keep that fun visual going on below. And let me know if you have any questions, or if, I don't know, there's anything you'd like me to explore in particular. Otherwise, I will probably keep hacking on this thing. But first, let me show off the actual code that renders this. So I have this little tour example file that does this whole thing. And the current way of defining this, maybe I'll get rid of the tour, or maybe I could throw it on the right-hand side or something. Oh well, I'll get rid of the fancy tour. It takes up too much screen real estate. It's still there. I'll just hide it. So yeah, panel position, right. Oh yeah, that kind of is hilariously large. There we go. Okay. So yeah, how does this work? So I have this application. How many lines of code? Okay, it's about 350 lines of code, but that's because I've got a whole bunch of silliness in it. Here we can see the giant terminal text block, which is a vertical stack of individual lines generated from an ASCII font website or something, and it's bold. I don't know if that matters. I don't know if that text can be bold exactly. I can try to remove it and see if there's any difference. Looks approximately the same. I'm not sure if it's any dimmer. I guess I like the idea of boldness, whether or not it affects the actual visuals. It feels more important to be bold. So yeah, and then here there's this overlay that says, you know, I am on alignment string of the world. That's that thing. And that's underlined. So you can just have text in a horizontal stack like that, and it will have by default one space. Actually, no, I've removed the spacing on either side. But the default would be one space, and that's all bold as well. You know, I can have other modifiers as well, like italic or strike through. And so that's kind of how you build up your views. So we have the alignment string, which is matching on these different alignments. That is part of the state in my app. So every tab has its own piece of state here. So this is the app you define. Basically, yes, to define a terminal application, first you make a struct that stores all of your application state. So I have this tab enumeration, which is obviously corresponds to which tab you're on, listed at the bottom of the screen there, and I'm cycling through those. And then each tab also has its own associated state, just to sort of better organize the application. And there's a default value. And so we're starting on the list tab. And then the frame tab, or this is the Z-stack tab, this has just an alignment setting, which is coming from the underlying Terminal UI library. So combination of a horizontal and vertical alignment. Looks like I actually already have a display instance for that. So I could probably remove this code and instead just do dot to string dot to uppercase, and that gets me some room back here. Is that going to work? Does that look all right? Yes, it's literally the same. Top left of the world, bottom left, bottom right of the world. Perfect. So that's cool. And yeah, so to actually implement, so besides having the state there, you need two things. You basically need a render method. So you implement this async terminal app. You take a render method that gives you yourself, and you can access all the properties you want on that thing. So basically I'm switching on tab, and then I have a helper function for how do you render each of those tabs. So when we're on the Z-stack state, I will yield to the stack tab view two things, which is a tick, which is used to render all these numbers in the background, and that's updated every 17 milliseconds, so approximately 60 frames per second, rounded up to the nearest millisecond, I suppose. I think it's like 16.6666. Repeating is 60 frames per second in milliseconds. Would be, yeah. Anyway, so, and then the tab state as well, which contains really just the alignment. And yippee. So that renders the view by picking a color for the alignment. And then, where's that color thrown in there? Oh, down here. So yes, the way it works is there's the Z stack. The background is these matrix number view thing, which is basically each line is the line number, and we get the width that's available to this view, which is the width of the terminal. And then I basically just repeat the line number plus the tick over and over again, so that each consecutive line number is one higher, and then as it ticks, every number gets higher and higher. And then I make a vertical stack out of that. And yeah, that's in the background. So the Z stack will render these things on top of one another. So if I put some IM on top, oh, nice. You already have it locally? That's amazing. So yeah, now that I've put IM on top there, that's also on top of everything else. So I can give this some padding, I guess, and maybe I'll give it a border, padding 5, and I'll give it a background color of red or something. So this is going to be quite large. Or I'll just do padding 1. So now I have another thing that's going to be rendered on top of that. So we could stack those things up as much as we want. Doesn't always look great. But yeah, that's so we can render pop-up windows or modals or something like that on top of other views. So it's very composable. The Z stack has an alignment, which we're using that alignment state to basically shift that around dynamically. Yeah, give it a whirl. It's very beta because I've been working on it for, I guess, a week and a half, and I've learned a lot about Rust, and it's I really, to be honest, like it a lot. It's really cool. Partly because of the tooling and just being able to have like an example directory and just run those like that. Really wonderful. Really, really nice. They really thought through a lot of things. So yeah, that's it for now. Oh, and then the other half of this is, of course, the updating, so responding to key events. So you have a render method and you also have an update method, which on the async view gives you the option to asynchronously send messages back to yourself, which I'm using here in the initializer. So there you have this initializer method that you're able to define, and if you do define it, it gives you this basically queue that you could send things to, send messages to of your own internal message type. And the way I'm using it is to just at the beginning, I spawn off something that will every 17 milliseconds send a new tick message, which we'll handle in our update method, just incrementing our tick by 1. I probably don't need to do a wrapping add because this would need to take a very long time to to do this, but I don't want it to blow up. So let's just have it, even if I want you to be able to run this thing for centuries. But yeah, if it's a normal key event, a queue will quit, tab will switch to the next tab. Also, I probably want to say if it's back tab, I will do self.tab previous, which I didn't implement, but I will have the AI implement now. So now I can hit tab, hopefully to go forward, and shift tab to go back, and that seems to be working, and the tab state is preserved between the tabs, so it'll stay down there in the bottom left, and so on and so forth. So pretty easy. I have another example here called to do, and I can learn Rust, check that off, move along. And something I was just experimenting with is the following. Where can I show this off? So I think if I go back to the tour, if I make this really small, how can I do that? Okay, I'll throw this back on the bottom. Nope, that's not what I wanted to do. Unsplit terminal. Move the terminal. Come on, terminal, move to the bottom. Panel position bottom. So if this is too small to render all of the items, they should stack up like this. And so hitting down, it'll sort of scroll through these things. But the unfortunate business is that it sort of, as you can see, sticks to the bottom here. So I'm going down to the bottom, it looks good. It feels good going from the top to the bottom. But once I hit up, I think that the slightly more intuitive UI response would be for just the item to go up to number 7, but not for 8 to disappear. I don't want it to be locked to the bottom of the screen. And the reason why it kind of is this way currently, and has to be this way currently, is because the view logic, that render method, can really just take the current state that's offered to it by the screen. And it cannot mutate anything. It's just purely, it's a pure function that goes from the current state to a view representation. And some views need some kind of internal state to track. Well, mostly here, this scroll view would need some internal state in order to track its current scroll offset and not just lock to the bottom. In that case, I could sort of just shift that scroll offset, but then when I go up again, 6 can remain on the screen, and just that cursor would go up to that next line. So I kind of need some way of rendering to update its state somehow. Something like this. Hello again, Pound. Good to see you. Ooh, I'll show you the pretty thing. Look at the pretty thing. Yay. It's fast now, and it can render a lot of frames per second. And how big can I make it? Pretty big. So it's feeling good. And I was just kind of walking through some of these little demos I made and some of the problems I'm trying to solve next. It would be nice to get a scroll view that doesn't have this behavior of locking to the bottom. I can show off what I kind of want, which is if I do something like the lazy get tool, which I like a lot, and here, so as I go down, it'll scroll down until it reaches the bottom, and then if I go up, it sort of scrolls when it looks like I'm 2 away from the top, it'll go up. But other than that, I can sort of jump between these two. But it has some memory, and I'm pushing it back and forth. Which means the rendering kind of has to know and save some stuff about the current offset. So the render method has to somehow store state. Oh yeah, lazy gets the best. The best. It's so fast. Which is the nice thing about terminal UIs. I think this one is written in Rust using a library called Bubbles. I've been doing a lot of research into different terminal UI libraries. Anyway, everything seems like it's working out pretty well, and it was pretty fun to implement, and I learned a whole bunch of things. It's kind of drifted from some other implementations. It's gotten a little more complicated as well. One thing, when I added this super fast, this 60 frames per second sort of demo of animated numbers shooting up, this was a little choppy at first, so it forced me to figure some things out. And one thing was I wanted the feedback when I hit left and right to feel immediate, and it wasn't. It was kind of getting clogged up by all those tick events, unfortunately. So I added some logic, which is a little ugly looking, but it seems to work really nicely. I tried refactoring this more, but it didn't really improve anything. Anyway, I still need to make this nicer, but basically what this does now is For a very short duration, a collect duration, I will read all the events I can, which might involve, I have a very small buffering window of where I collect all of the either keyboard events sent by the user or tick events or anything, and put these in some little buffers for a very small amount of time. And then I render only after handling all of those things. And I think there's a little bit of debouncing logic accidentally going on here as well. So that is, it just seems to work out really nicely. It made it really smooth. It's not the most beautiful code in the world, but it seems to go 60 frames per second and render a lot of stuff. So not that you need that for most terminal UIs, but I've just got a little obsessed and wanted to make it pretty and functional. So yeah, that's pretty exciting. It's fun to look at these fancy colors. Now I can make a GIF out of this and put it on the README. In terms of what to work on today, I mean, there was the scrolling view. Oh yeah. So let me open up this other thing, this to-do view. So if you'll notice in this one, I can add some to-dos, yay. As I mentioned, learn Rust, cross them off. But every time I make a move here, you'll see that the render count goes up by 1. And this is interesting because it's actually, it is the number of times that the render method was called on this. And I said that rendering was basically an immutable pure function, but I kind of cheated a little bit. And I was trying to see, can I have a view with internal state? And that's basically how SwiftUI works for real, is that they have this declarative view syntax, but views can have some kind of state. And it's fancy. It's kind of interesting how it worked. And I looked at a couple of different libraries and got an idea of how to implement that for this. And it's actually pretty straightforward once you have everything else in place. And it's kind of funny and hacky how it works. So I'm going to go to render counter, which is a built-in view here that I made that allows that to happen. That's basically what that view is. It's this render counter view. And the way this works is it's really hard-coded at the moment. The size is hard-coded, for instance, because I do not yet pass in the app state into the sizing view, which it kind of needs in order to know what it's going to even render to the screen, because it's rendering the current amount of times it's been rendered, so that will eventually affect its width. But anyway, I didn't feel like propagating that through every call site. Now I have enough views that it takes 5 minutes to update all the call sites, which is a little annoying. But basically the way it works is the app context, which is this thing that's passed down through each render call, and it stores the current color and the sort of the current view frame that view has access to and can render into, and a modifier, which is like a bold, dim, italic. And it stores it's sort of like an environment that's propagated down the tree. And I mean, that is what it is. And the nice thing about having the color and the modifier be in this context, which is what SwiftUI does, is because if I go to some kind of view here, let's go to the list tab view. No. Where's my Z-stack? Z-stack tab. Okay, Z-stack view. So here I can throw color on the entire V-stack. Like I can throw color onto some super view, some composed view, and it will basically, what that does is when you call color, it creates this context modifier view, which is a struct that has a child view, and then an optional color and an optional modifier. And it implements view, and its implementation is pretty simple. For size, it's simply, this isn't going to ever change the size, so it'll just delegate to the child. But for render, it will take the context and basically create a copy of it, potentially overriding the foreground color. So with foreground, if this is a sum, it'll override its foreground color. Otherwise, it will, Yeah, and then sorry, and then it's and then the modifier, um, which is interesting. I guess it says mute self here, which is kind of fascinating. So I'm guessing this kind of implicitly clones that thing. I actually don't know why it doesn't like warn me in some way. But I guess I am. It must be cloning here because this is not a mutable construct. So that's one of the things that sometimes confuses me about Rust. This does say mutable self, but it must be just this variable is mutable. I'm not really sure. Is context being mutated here? Look at the def of with foreground. No, it's not being mutated in the render method. The with foreground method, as indicated by its signature, takes self by value, not by reference, which means it consumes the current instance and returns a new instance with the updated foreground value. Okay, so it consumes it, and yeah. Which means, I think it means it's creating some copy. It is creating a new instance. All right. It's just interesting that it's not being cloned, but it is, I guess, yes, it would have to be a reference, because I guess when it's put into the stack, I don't really know. I have to work on that. There's so many variations of mute self or ampersand mute self, and clearly the fact that it's not a reference type here is what's allowing it to create a copy. But I'm pretty sure it's only creating one copy, and these subsequent ones are going to be modified instead of creating a bunch of them. I need to figure out at what point. But hello, other people. Looks like we have more concurrent viewers. Behold, 60 frames of terminal juiciness. Just currently walking through some implementation details, figuring out what we're going to work on next. Feel free to ask me any questions, and I will respond to them. Makes it more interesting than coding alone in silence. But it's fine if you just want to be rubber ducks as well. I appreciate your rubber ducking here. Just a number of ducks. Where are we now? So yeah, that's how they. What was I saying? Is that's kind of how these views are. These things like color work. They create this context modifier view, which just propagates, overrides the context, and then changes it down the. Hello, Stuart. Propagates it down the view tree, slightly modified, which is nice because otherwise you would have to you could only call color or with modifier on a text view, and you'd have to store it in the text view, and it wouldn't have this sort of cascading style sheets sort of effect where it affected the entire subtree. But this is a nicer way of doing it. So going back to the render counter view, which I opened in a new window. So going back to the render counter view, this looks at the context, but it actually steals this thing on the context called app state. And app state is a little tricky here. Currently, it's actually a mutable thing. It's just wrapped inside of a read-write lock. So this is the awful. If you want shared concurrency, you just have to. Rust desires that you ensconce your data types in a various number of wrapper types that add certain capabilities. So we have a read-write lock that's inside of an automatic reference counter. And this makes it basically, this little ritual allows it to be secretly mutable. So it is kind of like shared state, but because it's protected by this read-write lock, it's basically concurrency safe. And the arc allows you to clone it without actually cloning it. You're just bumping a reference counter. So you're actually sharing the underlying data, and it'll still be deallocated once it has no references to it anymore. So every time you clone it, it really just bumps the reference count, and every time you drop one instance, it decrements that reference count. When that reference count hits 0, it actually deallocates, frees up the memory of that read-write lock wrapped hash map of all this craziness. So the actual underlying thing to focus on, like when you read this, you just see, okay, concurrency safe shared data thing. It's a hash map from view IDs to a box of dynamic any's. And this box of dynamic anything is really just a way of saying this is anything. This could be any piece of data. And yeah. And the reason is because this is going to store any kind of state that we associate with any view. And that's why it's keyed by its view ID here. The view ID is a vector of numbers. And so the cool thing about this and how this works, and I stole this from pilfered from the RUI library. Pilfered with love from RUI. At least the general idea. I'm not sure if I changed it. It may call it view path in there or something. But basically, we have a tree of views. So we might have a vertical stack of multiple text views. Maybe this has an H stack. One of these does. And let's pretend that for some reason, actually maybe I'll replace this with view 1, view 2, view 3. So we don't know what these views are, but there's some particular type. And let's say they want to have declare some internal state that they can use. Well, the view, as we saw in the tour app, FN render, is constructed, it's just a value type. It doesn't actually it cannot contain any state inside of it because it's recreated from nothing every, 60 beautiful frames per second. Smooth as butter, but it has no state inside of it. It's totally ephemeral. It's just a value. Or it's being treated as a value. I don't know. In Rust, technically, whatever. You can make anything mutable, but we're just using it as simple value types, which means that they're not going to have any state. You can't actually store any state in there. But if you, outside of this, have some kind of, state map, which is that arc of read write lock of hash map view ID box anything, and if you have a mutable state map, when you call render on the view, you can actually propagate that state map down through the view tree. And really what you need to be able to, it's just as good. View 1 could either have state inside of it, or it can have some stable identifier that it can use to look up into this basically database that it can read and write from to its view ID and store any piece of state it needs into its little box type. And that's essentially equivalent, and it's good enough. So as long as when it's being created or rendered to the screen, it can just look into this, and therefore it basically has state. Now the challenge is just to come up with that view ID, because it needs to be stable across renders. Because it would be weird if, like, on render 1, if we have this, but then on render 2, we get rid of view 1. Well, view 2 is now where view 1 was, and so will view 2 accidentally inherit view 1 state? Like, how do we know? How do we give these things unique identifiers that are stable across re-renders? And I don't know if this is what SwiftUI if this was SwiftUI's invention or what, but it is very clever. And the way it works is you can't just have arbitrary, you actually can't do this. On a second re-render, you couldn't just remove a view from the view hierarchy. Instead, these views are all very sort of strongly typed. So if I go to well, I'm not going to go to that, but if I go to, where can I go? Yeah, let me go to if-then view. So if-then view takes a condition and 2 other views, a true view and a false view. And the render method is if it's true, if the condition is true, then it will render the true view. Otherwise, it'll render the false view. I should probably call this false view and true view. And if you see here, what this allows us to do is because we know the exact structure always, and there's always going to be this if then view determining this path, this condition, we can say the true, whatever view is in that true state is going to get 1 appended to this view path, this path of views. And so for VStack, basically its first child would get 1 pushed on to its, one pushed on to its view stack. So yeah, that basically the path starts out as an empty vector, and then these views render methods have to basically append a number to each child, so maybe 0 and 1. So the VStack will have 2 children, and so it'll, before rendering its first child, it will append a 0 onto that stack. It could have also just copied it, but for performance reasons, it's basically just because this is always rendered on the main thread and it isn't shared and it's rendered in order, we can just push and pop off of a stack. But whatever, you could also have like copied it and added something. So you're basically extending the current stack, adding on a new ID, which means that for this HStack view, when we get in here, our path would have been 0. And then for its first view, we'll sort of add on 1, if that makes sense. I'm actually going to move these things to the left, because maybe that's a little clearer. So yeah, basically, it starts out as empty for the VStack. Its first child gets a 0, and then for each of its child, each of its children, we append another number. And that will basically give it a canonical identifier to any particular view. It's not perfect yet, though, because I need to handle... So in one case, these HStack views are created. There's this thing called a tuple view, a view tuple, and they're all written with a macro. But if I inline it, we'll see that there's 1, 2, 3, 4 views. And this is basically in the type. So a view tuple will always have 4 views here. And so there will be this stable identifier. It's sort of when you create an HStack where you have 4 children, that child is going to be a view tuple where you have these 4 types, and it always has to have those 4 types across renders. It's going to be sort of statically enforced by the compiler, unless you do something crazy or wacky or no good. And I guess I do have to be careful about those cases in case we really do switch completely the type of view, and I have to think about that. I'm sure I have some bugs in the system, but that's the general idea, is that you have this shared state and then a stable path of identifiers, and that allows each view to have a unique and consistent key into the shared state map, and it can just share and overwrite what's in there. And so I basically tested that out in that very simple example here, where this render count stores its own state and modifies it, and it's able to use it between renders. I should probably do something else as well. It's a little weird in this terminal UI app because I'm not really going to expose this, I don't think, to like the user interface, just because it's kind of following the Elm architecture. In Swift, in a normal application where you might want each element to like handle click events or something, it would make sense potentially for each view to really, at the user level, track its own state. So you could have, a button or something, or a subcomponent, and the user can click left and right on that. But I feel like for terminal UIs, it's almost easier to just do what I have currently set up, which is just have a shared state and just have that top level state, basically. That just seems easier because basically you don't get click events. I mean, you can enable click events, but I think the way most terminal UIs work are via keyboard events. And so it sort of would, there's no such thing as focus. I could add focus, and maybe I will eventually, but it doesn't seem really worth it at the moment. So really what I want this state for is for the ability to implement things like that, the scroll view that remembers its offset and can scroll more nicely instead of the other way. So a lot of work to be done just for a simple feature, but I've think that that's a... It would be weird if that was the best scroll view you can get, where it sort of just clung to the bottom. It feels icky. I mean, it definitely feels nicer to be able to actually scroll up and down and, yeah, not just have it cling to the bottom. But for this to work, it needs to kind of remember where it was on the previous render, because it's not possible to know in your overall view state, you don't know yet how much screen real estate you have. And yeah, I guess you could track that on, you can like listen to resize events, but then yeah, you don't know where that view is going to be rendered. Basically that it would be easiest and make the most sense if the view itself knew both how much space it had to render itself and was able to sort of keep track of that scroll offset, and then that the user didn't have to worry about it. That would be kind of nice and magical. Ratatouille, you have to actually store that state inside of your overall app, but that's, I think, a little awkward, and it'd be nice if it can be completely abstracted away. And you can just say, yeah, give me a scroll view with these items, and it would just work. So that's something to work on. The other thing to work on is actually something that would be a problem at the moment. If I go to the To-Do application and we look at, and the To-Do app is only 200 lines, not so bad. So we create an app with some example to-dos in here. I think I made a new method actually, so I can get rid of those. And then what does it do? I need to go to the render method, so fn render, the top level render. So yeah, let me just show off the sort of the comparison of the DSL and what is actually happening. Hello, cross these things out. So the render will first render all the to-dos, which is a helper method. And then there's this shortcut text helper, which determines, it's a horizontal stack of the key and the description, which is called down here. So n new space toggle up down navigate. So each of those, as you can see, is in a horizontal stack. The key is bold, the description is dim. They're both blue, so we can put the blue on the H stack and it'll travel downstream. And then all of these commands are gathered up in an H stack and given some spacing. So there's 2 between each of these instead of the default of a single space that the H stack has. Which I'm wondering if I should just make it 0, but I feel most of the time in terminal UIs you actually do want 1 space, and you can always say dot spacing 0 if you really wanted to have no spacing. But I think that's a reasonable default. It's a little weird because vertical stacks don't have any spacing. Yay. But the problem, or the potential problem, is in this... Oh yeah, and then I'm rendering my render counter. The to-dos, this is a little awkward. I basically wanted to grow to fill up the entire space. Another alternative would be to do something like dot center, and then but then it would take up the center. And if I don't have anything like that, it would not take up the entire window. So I want that to-dos thing to actually grow to fill everything. And I should probably make a helper method. I actually do have one for fill horizontally and fill vertically. I can use both of those, but maybe I could just say fill, and it would do both. I don't like the word fill. I don't like that API name, but at least it's less verbose than that whole ugly frame thing. Okay, cool. So the issue that I'm going to experience eventually as a bug is in here, where render to-dos, it has the input view, which is only visible if the mode is adding, which is happens when I hit the N key. Hello. So there's that. And above that, and that's above the to-dos. And so a vertical stack can be created with actually a vector of views. And so each of these render to-do methods returns a different view, which is its... why am I doing it like that? I can just chain that on. There we go. So it's an H stack of the cursor. And if it's selected, it's an arrow. Otherwise, it's a space. And I should probably make this into some kind of like if-then else view or something. Here's one problem that I'm going to have eventually, and I need to figure out how to do that, because basically, if I don't have this as any business here, and I could say it's like going to be actually, I can't say an impl view. That's not allowed in that position in Rust, unfortunately. But even if I did pull this out into a helper method or something, it's going to say that these do not have, they have incompatible types. One's a context modifier and one is a string. And both of these types actually do implement the view trait, but it can't unify them. So we have to unify them in some way. And that's where, in SwiftUI, there's actually this thing called an AnyView. And it, yeah, actually, I think I know how SwiftUI must do it. Basically, in SwiftUI, you're not really supposed to just use a normal if like this. They have special syntax which will rewrite this if to basically use the if-then view, essentially. And I don't think I have a new method on this. And I wouldn't want to make a new method, so I'd have to come up with some public function like if-then, view, which is a little awkward. And I could do that, so let me rewrite this to be an if-then view. And now it does work, because it's okay that these two are different types, and I can remove the as any. Because they're allowed to be here. And by having it in this if-then view, its render method can handle mapping the IDs correctly, pushing a 1 in the true path and a 0 in the false path onto the view ID path stack thing, which will mean that if I have two views here that both require app state, they will not clobber each other, actually. And actually, let me show that off. Instead, I'm going to replace this with render counter. Both sides will be render counters. I think I could show off the problem. Let's see. So these are, it looks like render is called fewer times on them, I think. And I'm not entirely sure why. The top render count is called every time. Let me think. Cursor. Oh, I know why. And it's hard to see this because of, let me say color, I'll say blue and green, and then I'll go into the render counter, and let me make sure I actually use the context.foreground color. And sure, the context.modifier. This is a weird temporary view just for debugging purposes. So we'll see that there are actually two different views. One is blue, and let me add another to-do here so we can see it off. So they all have their own state, and the reason why they're growing at different rates is because it's swapping in. This one is now blue and has 0 because this was never selected before. So this is the first time that this view path is ever being rendered, because it's sort of the tree. I should probably have a view that renders the view path. In fact, I can do that. For this one, I can also render, and then I can throw the ID path. Join, not happy? Oh, because it's not a... maybe I could do like I don't know how to do the debug thing. Okay, let's see what that does. Aha! I'm going to make this wider. It might have a lot of numbers there. Okay, cool. So, as you see, the IDs are changing as I go and select these things. Which is kind of interesting. So you can see here, this must be that one vertical stack that they're currently in, which is they each get incremented by 1. Cool. And there's actually, I think, already a problem here. Maybe there isn't. which is, yeah, if I add a new one, it actually gets added to the top, which means that all the other states are, yeah, hello. This new one shouldn't have a value of 8 here, but this is one of the problems with having let me go to the actual thing that's causing this problem. I have a list, a vector of views here, and the way that the vertical stack is giving IDs to its children, if I go to its implementation, is that it's going to, where's push? It'll push the index of each child, because that's what it has access to. And that works fine if it's a tuple view where there's always going to be a constant amount of children between views. But in this case, the to-dos are able to grow and shrink. And so, in fact, I'm inserting new to-dos at the top, which means that the new to-do will inherit that value. So if I go up and down a lot, in fact, it seems to, yeah, something weird is definitely occurring here. So yeah, there's some kind of issue with the whole business of these multiple to-dos. Yeah, I actually don't understand. Oh, I know, they're getting cut off because I haven't given them enough room. So that's what's happening there. Render counter. Let me give it way too much room. And now if I go hello, cool. So every time I make a type, these are getting re-rendered again, right? Each time I make a type. That's not a sentence, but hello. But now that first one is 64, and the last one is 0, because that's a new, that got the new index. Cool. So the way to solve this is basically to not allow you to just have anyone to just have just a vector of views or a list of views that dynamically change just nakedly like this. If you've ever used React or SwiftUI, you'll know that when you want to increment over, sort of map over a list of things that you're going to render, you need to somehow give a key to each of those items. And basically that key can be what is used as the that identifier and pushed onto the view hierarchy. And so instead of just having a vertical stack here, and in SwiftUI actually you wouldn't be able to just put a list of views inside of a vertical stack. What instead you'd need to do is something like a for each view. And you would be able to say self.todos probably. And then you would have to give it a key, which I guess would have to be a function from to-do to something, which might be basically a to-do ID. Like we need a stable identifier for these to-dos, especially if they're going to change positions. And then we would need a function from each to-do to a view in some way. Which is a little awkward, and I have to figure out what's the best way of doing this API in Rust. But that would solve that problem, which currently, it's not really a problem because I don't expose that state to users, but I would like to solve the problem and maybe just learn more about how to do this thing. And yeah. Anyway, probably going to stop at this moment. I've kind of just done a tour of everything. I will end on the fancy thing because I should eat some dinner. But yeah, thanks for stopping by, and I might do it again, I don't know, over the weekend if I feel like it. Of course, no pressure to come, but it's thanks for stopping by, and I'll see you around. Peace.